Alright, so if you haven't already, go ahead and get your graphing calculator on, clear it out. So step 1, it says a particle moves along a straight line. For 0 to 5, the velocity of the particle is given by. So we're only going to be looking at this graph from 0 to 5. We don't care about what it's doing in the negatives. We don't care about what it's doing past that. So very first thing you're going to do is we're going to have to type this into your calculator to look at the graph. So pull up your calculator and click the y equals button. So turn it on, click y equals, and you should have the button or the screen that looks like this. It's going to say plot 1, plot 2, plot 3. And then you're going to start typing in the function. So to type in the function, it's going to be -2 plus, and then it's going to be parenthesis. And then you use this button right here, the one that says x, t, theta. You hit that button, and that's going to give you an x. You have to use x's instead of t's, x squared, and then plus 3x, and then it's close the parentheses, and then this button gives you exponent, and then parenthesis 6 divided by 5. And then to get back off of the exponent, you hit this little arrow button, and then you type in minus x to the third power. So it's going to be x, and then you hit this little caret button to the third. On your guys' calculators, when you hit the caret button, it's not going to look like mine. It's just going to have like the little caret symbol and then a 3. So once you have that in, you're going to hit the graph button, and it should look something like that.
Wait, how do we get off the exponent?
Hit the little arrows, like this right arrow button.
Yeah.
Yep. Hit that right arrow button, and that will take you off the exponent.
And then what do we put after the exponent?
Oh, like whatever, this right here, minus x cubed. So it's going to look like this. Now our question is find all the values on the interval from 2 to 4 where the speed of the particle is 2. So remember, we're graphing, this is velocity by time. So velocity is basically just speed without direction. But in this case, oh, I realized I didn't save it with the correction. This should say velocity on it, right here. So yours is going to say velocity. We're going to do velocity first, and then we'll do speed. For some reason, it like saved it, like dropped it way down here on this one. Okay, so to find that, we're going to go back to the y plot. You're going to arrow down to y2, and you're going to type in the number 2, because you're trying to look at all the y values that are 2. And then you're going to hit graph again, and you're going to get something that looks like this. So what we're now going to be looking for is the intersection of our graph and this horizontal line. So to find that, you can hit the button at the top that says trace on it. And then it's going to allow you to move up. So when I hit trace, I hit my arrow up so that I'm on the horizontal line. And then you can just move over to see where the lines intersect. So it looks like our lines intersect at about 0.86. And they also intersect at about or 3.2. Yeah, what's up?
My graph looks different.
Let me see. You put it to the double third power. You got to go back in and retype it.
No.
Okay, so did you all get to see these 2 points right here? Okay, so it says that we're looking from the interval for t from 2 to 4. So which of these 2 values do we care about? This one at 0.86 or this one at 3.2? 3.2. So on your homework, you're going to write, or your notes, you're going to write 3.2. So our t at 3.2 has a velocity of 2. So does anyone have any questions about why we only looked at that one?
Yeah.
No. Because the interval says in the interval from 2 to 4. So the other one fell outside of that interval. Make sense? Okay. Next one. This one here says we're talking about speed. So instead of velocity, we want to find speed. So what's the main difference between speed and velocity?
Velocity is speed with direction.
Good. So speed, we have to get rid of the direction by taking
Absolute.
the absolute value of the velocity function. So, some of your calculators will be able to do this, some won't. So you're going to go back to the y plot. You have to put an absolute value bar around this equation. So I don't think mine will do this. I'm going to have to retype the whole thing, but yours might. So when you hit the math button right here, and then you arrow over once until it says NUM for number, and then you should have a button that says ABS. That's what you want to use for absolute value. So you hit enter, and unfortunately mine makes me retype the whole equation, but yours might put it around yours. I'm not sure how it's going to work on yours.
No, it makes you retype it.
Okay, so we're going to all have to retype it together. That's okay. So I go to math, I go to absolute value, and then I just type the equation in again. I swear there probably is a way to do it without retyping it, but yeah, I don't know. I could be wrong. Calculators are not my best skill. Okay, -2 plus parenthesis. Just make sure you type it in correctly. Let me know when you guys are ready.
Ready.
So if you think you're ready to check it, once you type it in, you're going to graph it. And it should look something like this if you've done it correctly. So what you're going to notice is all that it did to change this is it took the portions of your graph that were below the x-axis and it did what with them? Flipped them up, right? So that's what it's going to look like. So now we're trying to do the same thing. We're going to be analyzing where we cross, where these lines intersect with the function. So you're going to go to the trace button again, and then you're just going to arrow over. I actually like to try to be on the horizontal line because it's a little easier to work with than the I can just go straight across instead of up and down. So it looks like I intersect again at about 0.86, which is what we expected. And then you intersect again at about 3.2, which we expected, right? Because it was the same as the last one. But then in addition to that, we also get a value at about 3.6. You see that, where we also intersect? So you can zoom in to see it a little better on here. I don't want to mess it up because it's hard to get out of it. But we also have another point of intersection here, additionally to the last one. So we intersect not only at 3.4 or 3.2, but we also intersect at 3.6 now. So why do you think there's an additional value when we're talking about speed instead of velocity?
Because it can go -2 in the other direction.
Good, yeah. So what he's trying to say is we're talking about speed of the particle at 2, which includes velocity of -2, right? So in addition to the 2 speed, we're also looking at the 2 velocity. So any questions about that? Yeah, Brandon, go ahead.
What's with those graphs at the start?
Oh, this is just a zoomed in version of the graph. Alright, so the next one, we're going to look at when the particle changes direction. So you can go ahead and graph this yourself, or we can just look at the picture here. So it's up to you. If you want to type in the graph and look at it and clear it out, that's fine. But let's talk about when a particle changes direction, how we can identify it. That's when we cross x-axis. So if we're looking at a velocity graph, we know that when we cross the x-axis, our particle is changing direction. Anybody know why that is?
Velocity is in that direction, and the zeros when it's not moving at all.
Good, yeah. So basically what that means is anything that you look at the positive x of velocity is when it's moving in the positive direction. Anything you look at for velocity under the x-axis is moving in the opposite direction. So that's when it changes directions, it switches. When velocity becomes negative, we switch direction. So on this interval alone in this picture, how many times did we change direction? 2 times. And the reason is because we crossed the x-axis 2 times. So that's something that I would definitely ask you on a quiz or test. I'd give you a picture and say, how many times did we change direction on this interval? You gotta look for when we cross the x-axis. Alright. And then the last one says, is the speed of the particle increasing or decreasing at time 4? Yes.
Did you ever establish a time for when it crosses, or do you just kind of guesstimate it?
Oh, for this one?
Yeah. Because it says find the time.
Oh, you're right, yeah. To find the times. So, yeah, to do that, we'd have to actually look at where it is on the graph. So I can show you how to do that. So if we go back here, we're going to clear out y2. And then you have to clear the absolute value bars. So my calculator will let me, if I just hover over the absolute value and I hit clear. Oh, just kidding. Wait. Sorry.
Yes.
I don't think you can undo it.
You
But.
can, you probably could if you place it as 1 instead of absolute value.
Oh.
Type it in.
It didn't work, so just kidding. Sorry. Don't worry, I've had to type this in 10 times to practice, so.
You can put a 0 instead of an absolute value, so then it's 0 minus 2.
0? What?
Like this. No, just delete the absolute value. Well, you don't have to delete it to turn it into a 0. You can just put a 0 there.
Oh, that's strange. Okay. Guess that works. Does it work?
No.
So much for that.
No.
I'll put a 0 on the other absolute values.
And you'll have to mute it.
There is no other absolute value. I don't know why it won't work.
It gets rid of it if you press the delete button.
Oh, it's probably because
Delete, that's what I meant to hit, yeah. Okay.
It does work.
So we're back to the graph. Okay, that's good. I'm glad it works. Alright, so we're back to the graph, and then we want to find all the times on the interval where the particle changes direction. So to do that, we would just hit the trace button, and we would just find where we cross the x-axis. So that's one way to do it. Another way to do it, if you want to get more technical stuff, if you hit the second trace button, you see how you can actually get a 0 right here?
Yeah.
So if you hit 0 and you hit enter, it'll ask you for a left bound and a right bound. It's kind of a pain. You have to pick a point below it and above it. You hit enter, and then you go to the other side of it and you hit enter. Wait, somebody asked a question?
No, you're good.
Oh, okay. So we have a 0 at about 0.5, and then I can use the trace button to find the other 0 as well. So you can use either option, whatever you feel more comfortable with. Our other 0 is at about 3.1. So the values are at t equals 0.5 and t equals 3.1. So that's just estimating.
You can sort of see that on the graph.
Yeah, you can sort of see it on the graph. I just want to show you how you could use the graphing calculator to find it in case you wanted to know.
Well, wouldn't it have to be precise?
Nothing on a graphing calculator is precise.
Or more precise?
Sure. Alright, does anyone have any questions about this one, or can we move on to the next? Okay.
Robert's question again.
So the next question says, is the speed of the particle increasing or decreasing at time of 4? Give a reason for your answer. So you can use the calculator to do this, but you don't have to. So if you hit the y equals button, and you hit the graph, you can go to second trace, and you can actually pick a value that you want to evaluate the function at. So you hit value, enter, and you type in 4. And you see how it'll actually give you the output value there? Did everybody get that step down?
That's really...
Alright, you want me to do it again? You guys ready?
Yeah.
Okay. So you're going to hit second, trace, and you're going to get a list. and you're gonna go down to the second option where it says 0, and you hit enter, and then you should be able, mine doesn't do it because I had to do it twice in a row, so hang on. So you go to graph, second calc, you type in 0, and then you hit what 0 you want, and it should give you negative 11.4. Do you guys get that?
Yeah.
Okay. So at this 0, or at this, x value, what is the y value?
Negative 11.4.
Good. So the y value represents the velocity, right? So we can say the velocity,
It's asking for the speed, so wouldn't the speed be increasing?
well, I'm going to get there, but I don't want to confuse anybody, so we're taking it one step at a time. Our velocity is approximately 11.5. So in order to find the speed, we have to see if the acceleration and the velocity are the same sign. You guys remember that from the last lesson?
Yeah.
So we have to determine if the acceleration at 4 is positive or negative.
Negative. Not the same sign.
Well, yeah, we want it to be negative. We don't know if it is. So let's look at our graph to determine if that's the case. So 4 is about here. So somewhere around here. Would you say the slope of the line at this point is positive or negative sloping? Is it going
Down.
decreasing or increasing? It's going down, right? So does everybody see how right here our slope is negative?
Yes.
Okay. So our slope of velocity is the same thing as the acceleration, right? So in this case, we can say that our acceleration is for sure negative. You don't have to know exactly what it is. I just have to know if it's negative or positive. Because if velocity and acceleration have the same sign, what do we know to be true?
Its sign increases its speed.
Yeah. If v of t and a of t are the same sign, we are speeding up. If they were opposite signs, we would be,
Slowing down.
yeah, go ahead.
If I said it was like moving further from the x, would that be, or from the x-intercept, would that be a
That would
viable
be
reason?
true, but it wouldn't be answering my question. Oh, you mean to use that fact to determine that it's speeding up?
Yeah.
That would be correct. But you'd have to say that it's speeding up to get the credit, yeah. So the speeding up, slowing down thing with the velocity being the same as the acceleration or being the opposite is like a really important concept for this. So just make sure you understand that. The one that you're going to have on your test and quiz is going to be algebraic. Like I'll give you a function and I'll say evaluate the velocity and the acceleration at this time and then see if they're the same sign or if they're opposite signs. Okay. So the next question we're going to be looking at is like a conceptual rocket question. So keep in mind, this particular graph is not talking about position, this is velocity. So this is strictly the velocity, rather not the speed, of the graph over time. So it says a model rocket is launched, the propellant burns for a few seconds, accelerating the rocket upward. After burnout, the rocket coasts upward for a while and then begins to fall. Small explosion charge pops out of parachute shortly after. The rocket starts downward and the parachute slows the rocket to keep it from breaking when it lands. This graph shows the velocity of data from the flight. So let's look at the graph and analyze like what's happening here. So this section of the graph right here, this is when the propellant is burning and the graph is accelerating. Okay? So this is acceleration right here. So any questions about how I know that that's acceleration? Okay. So what do you think happens right here at this cusp?
The engine stops.
Good. So this is where the engine stops. So when the engine stops, does that mean that it instantly just starts going down?
No.
No, it's still coasting upward. So think of it as like the rocket goes up really fast and then the engine stops, but it still like has that momentum to keep going. That right here is this whole section. So as you can see, it's slowing down, but it's still going up. How do I know that it's still going up? Because the velocity is
Still positive.
still positive. Not until we get to right here,
And down.
it starts going down. And then it starts going down for a while until right here. What do you think happens right here?
Parachute kicks in.
Parachute opens.
The parachute opens, and when the parachute opens, it starts slowing you down. You're going downward, but it's going now at a slower rate. And then once it gets, the parachute takes a minute to like open up, and then once it opens up, it stabilizes you so that you're going down at a very constant and steady rate, which makes sense because that's how a parachute works, right? You're still going to be coming down, but you're just going to be going at a very slow and steady rate. Okay, so now that we've seen and analyzed the graph, let's go ahead and answer the questions. So it says, how fast was the rocket climbing when the engine stopped? So what's the maximum speed that we ever reached?
Like,
180.
Yeah.
180 to 190.
190 feet per second. So that's the fastest it was ever going, and that's when the engine cut, and then it just started going slower. Still upward, but just slower. Next one says, how fast was the rocket traveling 4 seconds after it was launched? So at 4 seconds, what was the speed here?
Like 125.
125 feet per second. And at that point, it was going at a constant speed, right? For how many seconds did the engine burn? 2 seconds. Because after 2 seconds, it starts going at a constant speed because there's no more acceleration. I'm going to go a little out of order because the way I clipped them. How long does the rocket fall before the parachute opened?
Like 2.5 seconds.
Yeah, so the rocket is falling from about here to about here, right? Do you guys see that? So that's the falling. So it's actually about 3 because it's at like 11. So we're going to estimate and say 3 seconds. And if you're wondering like how I got that, it's because I took the 11 minus the 8. How fast was the rocket falling after the parachute popped out? So once the parachute like stabilized, it took a minute.
25 feet per second.
Yeah, it was going 20 feet per second once it stabilized right here. So as you can see, it stabilizes at this point right here at 20. So once the parachute fully popped out, we were going 20 feet per second. Now, why didn't I put the fact that the feet per second is negative?
Because you can, then you'll be falling negative direction if you're going up.
Yeah, essentially, like, since we're already talking about the rocket falling, we don't have to, like, double negative it with the negative, because we're indicating the direction with the fact that it's falling. And now it says find v prime of 6 given the practical interpretation of the context. So if we look at 6, they're asking for v prime of 6. What does v prime represent? The derivative, which is acceleration, right? So at this particular time, what do you think, like, what is the approximate slope here? It looks like it's going down 1 over 1, right? Down 1 over 1. So what's the slope going to be there?
1 or -1.
Negative 10, because it's going by tens, right? So yeah, I think it's tens, yeah. I guess, yeah, negative 10 feet per second. It's actually feet squared per second. Because
Oh,
Alright. And then, was the rocket going down or up 6 seconds after it was launched? So at 6 seconds, was the rocket going upward or downward? Upward, because why?
It still has momentum going up.
Velocity is still what?
positive.
Yeah, because velocity is positive. Anytime velocity is positive, we're traveling in the positive direction, whether or not we're going quickly or slowly. When did the rocket reach its highest point? So what was the time at which we reached the highest point?
8 seconds.
8 seconds. This one seemed to like trip people up. So the reason for that is because what happens at 8 seconds?
It flips.
It
reaches
Crosses
0.
the x-axis.
It crosses the x-axis, which means it changed direction. Prior to 8 seconds, did we ever change direction? No, we were strictly going up. So if you just keep going up, we're obviously going to reach its highest point before we start going down, right? So for that reason, 8 seconds. And what was the velocity?
0.
Good. So v of 8 is 0. The speed is 0 here because we have to change directions. When did the parachute pop out?
11 seconds.
Right around 11 seconds. And we know because no longer constant. Find the average acceleration over the first 8 seconds. So average acceleration, regular acceleration is the slope of velocity, right? So average acceleration would be like calculating the slope between 2 points. So over the first 8 seconds, that's from here to here, right? We're just calculating the slope between those 2 points. Is that going to be a secant line or a tangent line?
Oh, secant.
Secant line. This forms a secant line. Do you remember the difference between average rate of change and instantaneous? Average is a secant. So to find this, we would just find the slope of this line, which would be what?
0.
0. So the thing that's like tricky about this is the fact that you can see that we weren't just staying still, right? But because we went up and then down, the accelerations canceled each other out. That's like if you were to average like a really bad and a really good test score together, you're going to end up somewhere in the middle. Same idea here. So when was the rocket's acceleration the greatest? So when were we accelerating the most here?
2 seconds?
2 seconds.
Yeah, so we can't really tell because there's a cusp here. So what I just said to be safe is somewhere between 0 and 2 seconds, our acceleration was at its max. So that was when we were at the greatest, right? And then when were we at a constant rate?
8
Or from
2 to 8
15.
to 11.
2 until we get to
8.
11,
well,
right?
Oh.
Because over here we're not a constant anymore, right? We're only constant from 2 to 11. And then during what intervals are we speeding up versus slowing down? This is that whole concept of same sign, opposite sign thing. So let me just restate that in case anybody's confused. So from this section right here, first thing we look at, is the velocity positive there? Yes. Is the slope also positive?
Yes.
So for that reason, we're speeding up there. So speeding up is from 0 to 2. Okay. So what about from here to here? The velocity is negative. The velocity is negative. Is the slope also negative?
Yes.
So they're the same sign. So for that reason, it's speeding up from 8 to 11. Okay. And now we're going to look at slowing down. So slowing down, from here to here, is the velocity positive?
Yeah.
The velocity is positive because we're above the x-axis, but the slope is, so since they're opposite, we must be slowing down. So from 2 to 8. And then from here to here, our velocity is the velocity?
Oh, negative.
The velocity is negative because we're below the x-axis, but the slope is positive, so they're opposites, so we're slowing down. It's tricky, but you just have to think about it.
Would you do that one to infinity?
No, because we only have information up to about 12.5, so we can't say for sure what it's doing after that. Alright, I'll hand out your homework, and then you guys can let me know if you have any questions about it.